Yeah, Jenny, any ideas of what will happen? Any ideas? Any guess? So, Jenny, what are the options? The ray can undergo what? Refraction, so it could come out here. Or what? Probably total internal. Let's see if total internal will happen. The angle of incidence is what? 45, right? Which is greater than the critical angle. And where is the ray? In the dense medium or less dense medium? Denser. So I is bigger than C and the ray is in the. So what will happen? Total internal reflection. Right, question. What's the angle it meets in here at? 90 again. So what will happen? It will come straight out. You're okay with that? Just draw this up. Triangular prism. Triangular glass prism. Triangular glass prism. Those who come in the lessons, they might block the roads instead of walk on the street, right? There's block and people cross down there somewhere. Come on, come to start the what I'm coming for. Right, so take the small note down. Let me give you the steps. Step one, well, sorry, not step one. There's two complaining. Right, write this down. The ray enters the surface AB. The ray enters the surface AB at 90 degrees. The ray enters the surface AB at 90 degrees. And is undeviated until it meets the surface AC. Until it meets the surface AC. Full stop. Full stop. At EC, it undergoes total internal reflection. At AC, it undergoes total internal reflection. Internal reflection. Before exiting BC, before exiting BC, before exiting BC, undeviated, before exiting BC, undeviated into the air. Full stop. Right, you'll recognize that you bend the weight to how much? 90 degrees, right? Suppose you wanted to bend the weight 180. What you can do? Put the next one, right? We can put the next one here. Correct? Y'all see that? But suppose I want it done in one way. What you can do? Instead of using two ways, what to do? One way. How to align one way here? Sorry, one. Suppose instead of using two triangular prisms, I want to use one. Just show me how to draw it now. Suppose you want to bend it 180 using one prism. And the hint is watch two of them, and you can figure it out. You only have one prism, you can't join two of them. Draw. You figure it out? Change the orientation of it here, and how it will look. It will look like these two combined, right? So instead of using one, we could do something like this. We could do this. Instead of using two, we could just align one like this. The ray would enter here, totally internally reflect here. What will happen here? Total internal again. Right, that is B, and there's a different option, right? That's just bending the ray 180 degrees. I just show this. Right, the first one is bending 90, this one is bending 180. All right. All right, first one, we have four to do, so let's work fast. So what you see, right? Figure 4, what the question there? So what's the diagram there, right? Figure 4 shows a ray of light XY incident on a right angle prism, PQR, and they give you the refractive index. The incidence, point of incidence on PR is such that the refracted ray inside the prism PQ. All right? Calculate the angular refraction. Try that quick. What's the first thing you have to answer diagram? The normal, very good. Add the normal and then find the angle of incidence. What's the formula we're gonna use in part 1? Sasha, what's the formula you think we're gonna use in part 1 to find angle of refraction? Remember they gave us refractive index up there, what is 1.5. What's the formula you're gonna use? Second back pass. When you wanna give you. Right? Sign I and sign out, right? Try it quick. Then find part 2. You need to draw a diagram because they need it for part 2. Draw a diagram and follow the part that you read.
Yeah. Hello. Hello.
Yeah, get my message.
Yeah.
Hello. I'm on way to you now. I think I'm not remember your
Okay.
Carry on you reach your mic, right? Hurry up. So by now you should have your normal. Right? Species. You have your normal. How do we find the angle of refraction again, Joshua? How do you find the angle of incidence again? Between what? Between what? Yeah, but how will be done if I don't know that first part? Touch it up, help them now. So tell me how you find the angle of incidence. You'll measure your angle between you and you. So how much is there? 45 times. Right? Coincidentally, it works out to be the same thing here, right? But if that was 40, you could have gotten it wrong, right? Be careful of that. It's always the angle between the normal and the ray. Hurry up, do part 1 and then part 2 online or some answers, please. And your small answer, Christopher. Test your answers. Right? And remember, Sasha said that we're using this formula, right?
Yeah.
Hurry up, do this part fast too. All right, ready? Right, so when they use the formula, refractive index is 1.5. Angle of incidence is 45 over sine r. What do we do here? What do you do here again? Cross multiply. So you'll get 1.5 sine r is sine 45. If you want, you can work it out, but if you don't want to round up too much, leave it at sine 45, right? Move across the 1.5, and I have sine inverse sine 45 over 1.5. How much is that? 28.1 degrees, right? Does that make sense? Should it have been bigger than 45 or smaller than 45? Smaller, right? Because in a more dense medium. All right. So we do this one like this.
Wait.
So when you reach there, right? You have refraction. Right. What you say earlier? Here's the mass comes in, right? Well, watch the diagram, please. So I rounded off the angle of refraction to 28, right? So I put in the 28 degrees here. Everybody okay with that? Can you follow up with 28? I join it back in blue. Yeah? There's 28. Is it enough? So next to 28, how much is here? Right, so Olya, in order to figure out part 2, you have to do a bit of math and figure out all the angles. Right? What's the angle next to 28? What's the angle here? How much? 62? Are you okay with that? Why? Because here's 90, right? Nice. So if there's 62, how much is up here, Michael? Actually, same question like Dana. Same question I asked earlier. 45. Nice. Up there is 45, right? So how much is here, Diana? How much is that? Yeah, take it back. 73. Is that correct? 113. Well, 107. Nice. Wait a minute. Last part. We have to figure out the angle of incidence here. Right? The mark somebody online. Who asked online earlier? Rajiv, what's the angle I just drew there? I'll shade it here for you in case you miss it. What's this angle here? Rajiv? Rajiv said 20. Oh, he gave the whole answer. Very good, Rajiv. Right? 28. Not 28. 17, right? And the angle there is 17, right? I think he's, as I see it wrong. 28.1. Wait, no, bucket mass there with you. Make a little mistake. So the answer is 17, right? So what do you think will happen there? What do you think will happen to the rate? Akira. Here is 17 degrees. And they told you the critical angle is 41.8. What do you think will happen? Will it undergo total internal? Because it's smaller, right? So if it's not undergoing total internal, what will happen to the rate? It will undergo what? Refraction. Yeah? Right, sorry. So it will undergo refraction, Joshua. And it will come out like this. Well. Hold on, I don't want to make it the same. Right, so it will be refracted outwards. You're okay with that? Follow went on, Aria. Sure. Online, you're okay with that? So the only way to figure that diagram out, figure the answer out, you have to draw a diagram. Right? So your answer will be, after you draw it, I want to give you how you'll write it. All right. But you can answer what they say, right? So what you should say is that it will not undergo total internal reflection. It will not undergo total internal reflection because it will not undergo total internal reflection because the angle of incidence was 17 degrees, or you are going to it will not undergo total internal reflection because the angle of incidence is 17 degrees because the angle of incidence is 17 degrees, which is less than the critical angle. All right, so the only way to figure out that 17 degrees is you have to draw a diagram and do a little bit of maths and figure the angles out, right? That's okay? The question didn't ask you about if you want to figure out the angle of refraction, what to do. What you can do? Anybody? What should I give you here? They gave you the refractive index of what? They gave you the refractive index of glass with respect to air. Right? Now, what do I want? The refractive index of air. I just get that. 1 over If it's the first time you've seen it, write that down. The refractive index, you just flip it over. If it change the direction you're going from, flip it over. Right, so you just flip the answer over, so it could be instead of 1.5, it could be 1 over 1.5. And then it can work it out. Let's go again. Right, I hope you recognize that you need to know your little angles, right? The rule and angles, not triangle and thing, right? Next one. Ooh, one after. Down. No, if you want with, sorry.
Right.
Right, I will zoom in, but that's the best I can do there, right? Draw a diagram now. Draw a diagram. That is best I can do to zoom in there. You want to see a little bit harder, right? Once you can handle these well. Good. Right, so they give you all the reels, they give you all the angles. There are a few things to find out. This one. Right, and this question was nice to you, and they showed you the part of the reel. Right? You have to figure out angles, right? Anybody want to go ahead and we see that folks? Right, we don't have much time because we have 2 more to do cells. Before bell rings, so we're gonna go fast. Right, write this down. Find it, sorry, not find. The refractive index is 1.46. Write that down. Refractive index 1.46. Refractive index 1.46. You know, we do a flip class. Or I could go online, I could bring this whole group here. This whole online group here in person. I could get the parents' numbers. See? Javier there, Sterling and Odell. Serena the send, Rajiv send. Jenna, Marie. Jenna, you there? Right, part. Right, first part. Show that MN, sorry, show that MN will be totally internally reflected at AB. So we have a diagram there. You have to show that at MN, total internal reflection will happen. By the way, we all seen a totally internal reflect, right? At AB. See that? Clear? Clear? See that, right? You have to tell them why it happened. Pardon me, ma'am. What was the question? Show that MN undergoes total internal reflection at AB. Right? So put in all the angles. Put in all the angles. Oh yeah, well, 3 minutes. Yeah, put in all the angles. Draw a normal, eh? Besides figuring out the angles, draw a normal. That'll help you. Anybody have lessons in anybody have anybody have exam the last week of school? No, size of.
So when was that start?
Last week of school.
Oh, when is that?
Last week of school.
Yes.
Nobody have exam the last week of school?
So what?
Well, have last in school? No exam. We could know you're finishing that song. The week after that. Right. How much is here? 90 degrees. So how much is here? 30 degrees. That's okay?
Yeah.
So therefore, how much is here? 60 degrees. Can you explain now why total internal reflection happened? I think somebody online now. Who most likely listening? Cassie, are you there? Cassie, could you explain why total internal reflection happened here? Why did total internal reflection happen there? So question, is the rain denser medium on here? Is the rain denser medium? Yes. So number one, M N is in the denser medium. And M is in the denser medium. You okay with that? Is 60 more than the critical angle? We don't know. And Aaron, did we find the critical angle? No, Aaron's help out now. How you find the critical angle? What's the formula? You can look back. Critical angle is what? The formula. Last week. I didn't write it this week. So sine inverse 1 over 1.46. How much is that? $43.2. Right? Critical angle is 43.2. So will total internal reflection happen? Everybody want to? Oh yeah, yeah. Why one good back?
But imagine this versus one and you just think once. Now it's
So number one, it's in the tensor medium. Number two, the angle of incidence bigger than the critical angle. Yeah. Everybody okay with that? Clear? Follow why, right? So total internal reflection happens because of those two things. Any questions earlier? Huh? The rate Mn in the denser medium in the reflective material and angle of incidence is 60 degrees. And the critical angle was 43.3. So it means it's larger. So therefore, total internal reflection will happen. Okay, once those two things happen together, it will undergo reflection. So it means that here is 60. All right. Find the last part, find theta m. Find theta m. Find theta m. How you know? Find theta m quickly, Nathan. Theta m. Oh, you got it. Right? Can we finish two questions and probably? Right, help me find theta b. Sorry, theta m. Help me find theta m. What did pick one of them? Next, start it up. Sophia. Sophia, can you help me? What's the angle here? 30, nice. And how much is theta m then? Theta m is how much? Yep, 20 degrees. Huh? Theta m is 20 degrees. And last part will go tell you. Sketch the ray from P. So sketch the ray of the parcel. Right, last part. Last part, you have to draw what will happen to the ray after. Right? Try to figure out what will happen to the ray after.
Oh, it was, but that was like that. Okay, so. Oh, that's what I'm saying. Nice.
Right, so last part, we still have one more to do, Vishish. I know you're excited to do the next one. Did you answer any? Which one? Huh? Oh, no. So you gotta get one right. So your care is 20, Vishish. How much is here? Here. 7. What do you think will happen since the angle is 70? Is the range dense or medium? Yeah? Right. And what's the next thing you have to check for? Is 70 degrees bigger than the critical angle? So what will happen now? What to undergo? Come on, 3 in a row. You get 2. Okay. Total internal reflection will happen. You okay with that? Total internal reflection will happen. Right, number our angle is not shown perfectly, yeah? And then, well, it might refract out here after. Everybody okay with that? Online, you all okay what happened? Test here. Right, you follow what happened to the ray? Why it underwent total internal? So it underwent total internal 2 places, N and T. You okay with that, Leon? What is it? Malia. I know it was Malia. Everybody okay with that? One more. I know we don't have much time, but everybody right in there? Last one. They want us to find theta 1, theta 2, theta 3, theta 4, theta 5. All right, think of theta 2 and that easy to find. Theta 2 is what? Theta 2 is the same as?
Theta 1.
And theta 4 is the same as theta 3. All right. Hurry up now. So you have to find theta 1, 2, 3, 4, 5. Right, all they gave us is the refractive index of air to medium 1, medium 1 to medium 2. Yushish, hurry up now. Last question. Right on the values, right? Alright, we don't have much time. Tell me the formula we using. Let's pick on somebody new. Deja. Any new? Just have no work this out. I pick anybody name. What's the formula you're using? What's the formula for refractive index? Right, sine I over. They gave us the refractive index A to medium 1. 1.2 is equal to. What's the angle of incidence? Measure. And then cross multiply and work it out. Tell me where you get power or not. Work it out fast.
I can't say that.
46.2. So that is your theta 1. How much are they getting at? Divided by 1.2, right? Only theta 1 is how much? Right, 46.2. And theta 2 is what? 46.2, nice. And how do we get theta 3 megon? Next megon. What's the formula for to find theta 3? Same formula megon. So it's sine theta 2 over. What's the refractive index we're using now, Navia? 1.25, right? 1.25. So that's sine 46.2 all over sine theta 3. What you all got for theta 3? How much? 35.3. What is theta 4? Thing. 35.3. And theta 5. What do you think theta 5 will be? Step 1. After already. Taisha, what's it? Yeah, what's theta 5?
No.
What are we doing? What's theta 5? Anybody can help us? What's theta 5? That's the angle of what?
Alive.
Angle of emergence. Angle of emergence here would be 60 degrees. No? You should know about it. Oh. All right, nice. Copy it down. One line. When you're done, that's it, right?